I am Michio Kaku, physicist, futurist and author of The Future of Humanity IAmA. I'm a physicist and my primary vocation is doing theoretical physics, on paper, by hand. I also have a passion for explaining science, so I've written a number of popular science books about hyperspace, the physics of the impossible, the future of the mind, and more. My latest, out now in paperback, is about the future of humanity, on Earth, across space, throughout time, all the way to our destiny among the stars. Read more about the future of humanity here. https www.penguinrandomhouse.com books/555722 The Future of Humanity by Michio Kaku /9780534,434,542 proof https:// twitter.com Michio Kaku status /11204042213696962565 Fire away. I'm ready for your best. I'll be signing off now. If you have more questions or I wasn't able to get to yours, I'll be doing a Facebook Live on Tuesday, April 30th. Hope to see some of you there. Thanks for your comments and curiosities.
Sosa95 says, what do you think is the most important thing the average person should know about the universe?
Michio Kaku author replies, one thing that people should know about science in general is that science is the engine of prosperity. All the wealth we see around us is the byproduct of scientific discovery. Concerning the universe, the average person should appreciate the fact that the universe is knowable, that is, with enough time and effort, we can explain the great mysteries of the universes, without resorting to magic.
The M-Density says, what is your opinion on the simulation hypothesis?
Michio Kaku author replies, I do not think we live in a computer simulation. No digital computer can compute all the motions of molecules in a simple object, for example the weather. The smallest object which can simulate the weather is the weather itself. When you add quantum corrections, then no digital computer on Earth can simulate the quantum effects in the weather. So no digital computer can possibly simulate reality as we know it.
Frog Kid Frank Reynolds says, with the first picture of a black hole being revealed, what do you think is the logical next step to learn more about them?
Michio Kaku author replies, the next step is to release the data from the black hole at the center of the Milky Way galaxy, which weighs about 4 million times more than the Sun. Personally, I would be interested in studying spinning black holes, since, mathematically speaking, they might have a spinning ring in the center, which might, possibly, be a gateway to another universe.
Lola Liggett says, thank you for your AMA. What do you think is the most fascinating thing we might be able to see in our lifetime? Anything you really want to see happen in your lifetime?
Michio Kaku author replies, I think in this century, not necessarily in our lifetime, we will have our first starship sent to the stars, for example perhaps a computer chip. The theory of everything will be proven. The genes controlling the aging process will be found, BrainNet will be established, and we will detect the signals from an extraterrestrial civilization.
Exodus 111 says, what's your preferred Fermi paradox explanation?
Michio Kaku author replies, personally, I think alien civilizations exist in outer space, but distances between stars are so great, they would probably have to be type 2 or 3. This means there are perhaps several thousand years to a million years ahead of us. To them, we might appear to be like forest animals, like deers. At first, they might want to talk to the deers, but eventually, since the deers do not talk back, and lose interest, and leave the deers alone. Hence ETs in space realize that we have nothing to offer them, but they will not want to plunder us for resources, because there are plenty of uninhabited planets out there to plunder without worrying about the restive natives on them. MMG45 says, remember reading Parallel Worlds and you spoke of how long it would take for space travel to advance to a suitable price per weight. Has it progressed faster than you imagined in recent years with private companies like Space Capital X and Blue Origin, and do you think it is the beginning of a large step for mankind? By the way, I would just like to say thank you for starting my love of physics. Michio Kaku author replies, we are seeing a shift in thinking with the coming of Space Capital X and Blue Origin. The SLS booster rocket, funded by NASA with federal funds, is behind schedule and over budget. Worse, it may cost billion per mission and fly once a year. Meanwhile, Space Capital X with the Falcon Heavy claims to be able to send a rocket to the moon at a fraction of this cost and several times a year. So we are seeing that private enterprise may kickstart the space program.
Hobby says the big question, 2 parts, if you don't mind. 1. Do you think that there is a way we will discover a way to theoretically cheat the speed of light, warp drives, stable wormholes, etc., to allow for practical travel of vast distances across the universe? 2. Do you think that, even if we discover a way that it was possible, that we as a species, perhaps in a far-flung future, could ever develop some kind of technology to allow it to actually happen? Interstellar travel has captured all of our imaginations, but it's hard to imagine how it might be made a reality. Thanks for the IAmA. I've been a big fan of yours for a long time.
Michio Kaku replies wormholes that can break the light barrier are allowed within Einstein's theory, since they were introduced by Einstein himself in 1935, but going through them is problematic. First, you need to have the energy of a black hole to open the gateway to another universe, so don't think that an inventor will create a wormhole in his or her basement. Second, you need negative energy or matter to stabilize the wormhole so it doesn't collapse. Negative matter has never been seen in nature, but negative energy has been created in the laboratory, but only in small quantities. The energy necessary for all of this is the Planck energy, or 10 to the 19 billion electron volts, the energy at which space-time becomes unstable. Perhaps only a Type 3 civilization can manipulate the Planck energy.
Rupert says, can you help me understand how black holes can radiate away their mass through Hawking radiation? How is the mass energy leaving the gravity well of a black hole? It is said that Hawking radiation is a result of quantum field interactions near the event horizon, but this doesn't translate for me intuitively.
Michio Kaku replies, many textbooks say that black holes are black since not even light can escape. Nothing can escape a black hole. However, this violates the uncertainty principle. Pure blackness violates uncertainty, since pure blackness is the absence of all matter and energy, but the position and velocity of particles is always uncertain. Hence, black holes must be gray. That is what Hawking found. Surrounding the black hole, there is an event horizon, a sphere. If you are outside the event horizon, then you do not necessarily fall in. Hence, Hawking radiation can escape the black hole. However, it is very small. That is probably why Hawking never won the Nobel Prize, since the prize is usually given for physical discoveries that can be measured. Sherpa for Cardinals says, in your opinion, what are we losing as we invite more and more technology into our daily rhythms and habits? Michio Kaku replies, in every revolution, we gain and lose. As a student, we used to have slide rules on our hips. It was our symbol. Engineers considered it a badge of courage. Today, the only place to find a slide rule is in a museum. So we lost slide rules, but gained cell phones and pocket calculators. So technology continually shapes our daily life. Some people claim, however, that kids spend too much time online. My attitude is that a new social norm is being created, so that kids should by all means engage in online social interactions, but they must also be socialized, so they can interact socially with their peers. As long as kids have healthy relationships and friends, I see no reason why they shouldn't be online. BK2303 say, seem here about asking some personal opinion from you. I wanna become a theoretical physicist, but I'm facing constant failure to crack the entrance exams to get into high-quality universities. In order to be successful, should I do UG on normal colleges or should I only try to focus on getting into those universities? Dr. Kaku? Michio Kaku replies, to become a theoretical physicist, it certainly helps to go to a top-notch Ivy League school. I went to Harvard, but it is not absolutely essential. Most of the advanced material necessary to become a physicist is found in graduate school, not undergraduate school in a PhD program. That is where your true talent as a mathematical physicist begins to shine. So it certainly helps to get into a good school, but only as a PhD student in grad school do you begin to flourish as a research scientist.
Frank Moses, what do you think about Elon Musk's Neuralink technology that will connect humans to computer technology, and where does that potential put us on the long-term Type 0, Type 1, Type 2 advanced species spectrum?
Michio Kaku replies, maybe it's a bit premature to invest in brain-computer technology, but the field is rapidly moving ahead. Telepathy, forms of telekinesis, photographing thoughts, etc. were all once considered impossible, yet we can do them now, via physics. Eventually, we will have BrainNet, with the ability to send emotions, memories, feelings, etc. on the internet. This could rapidly reduce boundaries between people, and correct misconceptions between nations, as well as open up entirely new areas of entertainment. The movies and TV will seem so old when we have BrainNet.
SUPERT76 says, do you think a solar flare could wipe out humanity?
Michio Kaku replies, a giant solar flare can wipe out modern civilization, but not humanity itself. We now know that the Earth suffered 2 giant solar flares, in the year 775 and 1849. People back then felt nothing, since electronics as we know it did not exist back then. But another Carrington event of 1859 could set back world civilization 200 years. Power stations would short-circuit. Satellites would be fried. Blackouts would be planetary. The internet and all telecommunication would be destroyed. We physicists have estimated that property damage would be $2 trillion.
Aranthenia says, what progress in space travel do you foresee in the next 100 years?
Michio Kaku replies, we are entering the second golden age of space travel. The first golden age took us to the moon, but absorbed 5% of the entire US federal budget, so it was unsustainable, and eventually collapsed. But the second golden age of space traveler is being partially funded by billionaires, is benefiting from the reduced cost of space travel, will be fired up with reusable rockets, benefiting from the computer revolution. Hence, I think one day our grandchildren will be able to honeymoon on the moon, and a self-sustaining base will be on Mars. Remember, the dinosaurs did not have a space program, and that is why there are no dinosaurs today.
Willivan V says, Dr. Kaku, given the opportunity to merge your consciousness with a non-biological interface, would you? Do you think a copy of ourselves is made if consciousness is transfed, or will it be truly us?
Michio Kaku replies, I think that in this century, robots will not attain human-level consciousness. See my book The Future of the Mind for a definition of consciousness. But eventually digital immortality becomes possible at the end of the century. Already, it is possible to digitize all your emails, credit card transactions, videos and pictures, to create a rough avatar of yourself. In the future, instead of reading of Winston Churchill, you will talk to him. A holographic image of Churchill will appear that has all his speeches, books, bios, etc. I personally would love to talk to Einstein. Eventually, we might be digitized and become immortal. But is really us that becomes immortal? If our soul is actually information, and this information is digitized, with all our memories, then this copy might be indistinguishable from us. By the end of the century, the Connectome project may be finished to map all the neural pathways of the brain, so that we have an exact neural copy of our brain, so digital immortality might be possible. It becomes semantic whether the copy is a true copy, since the copy is indistinguishable from the real one.
Sporophyte says, are there any ways that the existence of 5 or more dimensions could impact us that we don't realize?
Michio Kaku replies, if string theory is correct, then we have no direct contact with hyperspatial dimensions, since they are too tiny for atoms to enter. But consider this, our universe is a bubble of some sort, and it is expanding, and we live on the skin of this bubble. This is the Big Bang theory. But string theory says there is actually a multiverse of universes, like a bubble bath, with bubbles colliding and fissioning all the time. So Big Bangs are happening all the time somewhere in the multiverse. This multiverse is the hyperspace of 11 dimensions.
Pramit57 says, do you have any advice for young scientists who want to explain science to the public, in both written and oral forms? How can a scientist make a career out of it?
Michio Kaku replies, I am a research physicist, spending most of my time working on the mathematics of string theory. However, I have the ultimate respect for professional science writers who base their careers on science education. For advice, I would say that a science writer first has to master as much science as possible. Second, this science has to be explained in terms of physical pictures and concepts, rather than just memorization. For example, learning about plants is fine, but simply listing the parts of a flower is boring. What is more interesting is how plants evolved, which explains their coloration, their shape, their life cycle. Once, the father of the young Richard Feynman would explain to him everything about the evolution of birds. But one day, a bully challenged him to name that bird they just saw. The young Feynman knew everything about that bird, the shape of its wings, beak, its habit, except its name. Then the bully said that Richard must be stupid because he couldn't name that bird. The young Feynman suddenly realized something profound. Most people think science is giving names to things like birds, but that is not science at all.
Feynman says is string theory on its way out the door?
Michio Kaku replies the progress of science is largely independent of public popularity. Science is not done by popularity contests on game shows. It often takes decades for scientific theories to be vindicated, yet the public often wants immediate results. The public wants breakthroughs for the moment, but science progresses at its own pace. Presently, string theory dominates much of theoretical physics, but lacks immediate experimental verification. The Large Hadron Collider found the Higgs boson, but failed to create dark matter. Unfortunately, many physicists believe that dark matter consists of the photino, a supersymmetric partner of the photon which is stable but invisible, and is predicted by string theory. We will have to wait until more results from the LHC come in. Also, the next generation of accelerators beyond the LHC are being discussed now, with proposals from Japan, China, and the European Union. Perhaps the next generation of accelerators, or perhaps results from spark chambers deep in the Earth, will pick up evidence for dark matter, which would be tremendous boost for string theory if the theory matches the data. Meanwhile, scores of physicists around the world are still finding new and fascinating discoveries about the nature of string theory.
RICCTP6 says I just have to say that I am one of your biggest fans. I'm an archaeologist and writer, and you make theoretical physics something I can at least begin to understand a bit. I was wondering if you could talk to us a bit about your writing process. Do you have a routine? Did you find that it easier to write popular novels than academic articles or vice versa? What is the hardest part about making complicated science relatable and clear for a general audience?
Michio Kaku replies I am a research physicist. I spend most of my time thinking about equations and manipulating them. However, I am also a science junkie, and seek out science on my own. Being a professor, I also am interested in science education. Hence, it was natural that I try to engage the public with a fascination about science. Unfortunately, there is no gene for the scientific method and mathematics, but there is a gene for wonderment and curiosity. The hard thing is to channel that natural inclination towards curiosity and a sense of wonder without sacrificing scientific rigor. But since I have interviewed over 300 scientists while working for BBC, the Science Channel, etc., it gives an appreciation for all the fantastic developments in science as a whole.
Mafaokbug says where do you see humanity in the next 100 years?
Michio Kaku replies in the next 100 years, we will see the birth of a Type 1 civilization, a planetary civilization. The Internet, for example, is the first Type 1 technology to appear in this Type 0 civilization. We see the beginning of a Type 1 language, with English and Mandarin Chinese being the first and second language of the Internet. We see the beginning of a Type 1 economy. With the emergence of planetary agreements we see the beginning Type 1 music, fashion, sports.
Bjorn 171 says does space and time fabric have surface tension, as in the only thing strong enough to puncture it is a black hole?
Michio Kaku replies space-time has no surface tension as we know it, but we have something called frame dragging. When a black hole rotates, it drags space-time around it, like Melissa's. Stars and gas follow the frame dragging space-time, but at the very center, it might be possible that space-time itself begins to rip. Stakatsu see verb in loving your book. Absolutely visionary. I appreciate your unashamed fusion of science and the imagination. Which brings me to a question that may seem spiritual. You mention the Star Maker in your book. Do you personally believe, after studying the complexities of the universe and the multiverses, that there may very well be a Star Maker? Do you believe that technology can allow humans to transcend the physical form and exist at a higher dimensional state? Michio Kaku replies in my book, The Future of Humanity, I mentioned the Star Maker, as celestial being who could manipulate entire universes, and witness the panorama of the multiverse. This was a stunning vision for the pre-war generation. I mentioned it because that is how we string theorists sometimes feel, as we manipulate solutions of string theory. Each solution of string theory represents an entire universe, with different laws of physics. To study string theory, we not only have to study our own universe, which is but one solution of string theory, but also universes that do not exist, at least in our neighborhood of the multiverse. Hence, we feel like the star maker. Instead of studying just our universe, we have to study universes that don't exist with different laws of physics. For example, some universes may have protons which are unstable, so the universe dissolves into a mist of electrons and neutrinos, or universes with a stronger nuclear force, so stars burn out quickly, and life cannot get started. However, this was only meant to be an analogy.
Ned Radnad says, when are we getting flying cars and when can I expect HD displays inside my contact lens?
Michio Kaku replies, flying cars are finally coming. I spoke in Dubai last year, where they are actually in negotiations for introducing flying cars. The problem was never the technology, the problem was getting cost down and solving political issues. Internet contact lenses will take longer already, as is possible to put chips into contact lenses. Diabetics can use this to monitor their blood via these contact lenses. Putting chips into contact lenses can be done. One problem is heat generation. Heat must be dissipated so that it does not pose a problem, and the optics has to be perfected as well. This work is being pioneered at the University of Washington in Seattle.
S1GN1FY says, do you believe that ITR and other fusion technologies will solve energy problems and alleviate some of the factors causing climate change in time to make a difference in the overall health of the planet and improve the quality of life in underserved parts of the world?
Michio Kaku replies, personally, I hope that the ITER fusion reactor in South France will be a success, so that one day even seawater can be source of hydrogen, which drives our fusion reactors, producing minimal nuclear waste and posing no problems with meltdowns. However, the ITER has been delayed several times, and HINSE still has not proven that fusion can help solve our energy problem, so it is still a distant but promising hope. More immediate is the falling cost of battery power. We forget that the problem with solar and wind power is storage. Since the sun does shine at night and the winds don't blow all the time, there is no Moore's law for batteries. But recently, there has been a dramatic fall in the cost of batteries, which might fulfill the dream of having solar and wind power fully competitive with fossil fuels.
Radiofiend says, in 200 years, if humanity is still around, what do you think the history books will say about our current era?
Michio Kaku replies, in this century, technology will give us AI which can usher in prosperity and growth. But by the end of the century, our machines may gradually become self-aware, and hence pose an existential risk to us. At that point, we should put a chip in their brain to shut them off if they become too rebellious. But 200 years from now, our machines will become so powerful they can remove all fail-safe systems and pose a real threat. At that point, we might have to merge with them. So the 21st century may be the last century when we are purely biological.